In last part, we have seen the meaning of median and calculation of median from ungrouped data as well as from group data. In this part, we are going to discuss about the mode, the third measure of central tendency, the mode. Now, mode is a score on score series which occurs most frequently. That means the score on score series whose frequency is maximum is called the mode. Now, let us consider the example. Find the mode of the following scores. Say first set of scores as 15, 14, 8, 14, 14, 11, 9, 9, 11. Mode is a score which occurs most frequently. So we have to find out the frequency of each score. These some scores are repeated and some are not repeated. Now we consider from lowest score. So consider the score and we find the frequency. Now 8, then 9, 11, 14 and 15. Now we count the frequencies of the scores. Now the first score is 15, so 1, then 14, then 8, then 14, again 14, then 11, then 9, again 9 and 11. So frequency of 8 is 1, frequency of 9 is 2, frequency of 11 is 2, frequency of 14 is 3 and frequency of 15 is 1. That means we can say that 14 is a score in score series which occurs most frequently. Its frequency is 3 and the frequency 3 is highest frequency. So mode of this distribution is 14. Mode is denoted by MO. So MO is equal to 14. Now consider second set of scores 23, 34, 37, 35, 20, 37, 23, then 40, 34, 37, 41 and 34. Now here also we find the frequency of each score. So lowest score is 20, then 23, 34, 35, 37, 40 and 41. And their frequencies, we count the frequencies as 23, then 34, 37, 35, 20, 37, 23, 40, 34, 37, 41 and 34. That means the frequency of 21 is 1, 23 is 2, frequency of 34 is 3, frequency of 35 is 1, frequency of 37 is 3 and frequency of 40 is 1 as well as frequency of 41 is 1. That means if we observe the frequencies, then 3 is the highest frequency. But there are two scores whose frequency is 3. That means frequency of 34 is 3 and frequency of 37 is 3. That means in this distribution there are two modes. Mode is equal to 34 and 37. It has two modes. That means we can say that the distribution may have more than two modes. More than one. Now consider the set of scores and we have to find mode of these set of scores. These scores are 24, 18, 19, 12, 23, 20, 21, 22, 27. If we observe that the frequency of each score is 1. Is equal to 1. That means highest frequency is 1, and 1 is the and each score has frequency 1. In this case, the score series has no mode. That means we can say that it has no mode. Mode does not exist in this case. Again, if we consider the set of scores as 18, 19, 24, 20, 24, 25, 18, 19, 21, 21, 20 and 25. Then again we observe in this set of scores that each score repeated twice. That means frequency of each score is equal to 2. Is equal to 2. In this case also the distribution has no mode. That means we can say that the distribution may have or the distribution has single mode as well as in sometimes more than one mode or no mode. Now we consider the calculation of mode from grouped data. Consider the example. Compute the mode of the distribution whose mean and the median are 72.66 and 72.25 respectively. Now, in such a type of distribution, the formula for calculating mode is used as mode is equal to 3 into median minus 2 into mean. That means mode MO is equal to 3 into MD minus 2 into M. Now here we have to given the mean and median. Mean is equal to 72.66 and median is equal to 72.25. So we can find mode is equal to 3 into 72.25 minus 2 into 72.66. So which is equal to 216.75 minus 145.32 and which is equal to 71.43. That means when the median and mean are given the of the distribution, then we can find mode by using the formula mode is equal to 3 into median minus 2 into mean. Separately also we can find the value of mode from group data. Consider the example. Compute the mode of the following distribution. The class intervals and frequencies are given and we have to find out the mode. For finding mode, we have to use the formula mode is equal to L plus FO minus F minus 1 upon 2 FO minus F minus 1 minus F1 and whole multiplied by I. Now, what are these notations? For this, we have to firstly decide the model class. That means the class interval in which the mode lies. Now, consider the class interval whose frequency is highest. So highest frequency is 30 and the class interval is 25 to 29. That means it is a class interval of mode. Mode lies in this class interval. That means mode. Now, when we consider the model class, then we can say that what is L? L is the lower limit of model class. Then FO is the frequency of model class. Now, frequency of the class interval in which mode lies is 30. Then F minus 1. F minus 1 is a frequency of the class interval below to model class. Then F1 is the frequency of class interval above the model class. So, if we consider the values, then in this case, our model class is 25 to 29. So, its lower limit is equal to 24.5 plus. Now, FO is the frequency of model class. Model class is 25 to 29 and its frequency is 30. So, FO, that means F0 is equal to 30 minus F minus. F minus is a frequency of a class below mode class. So, model class is 25 to 29 and below its the class interval is 20 to 24. Its frequency is 25. So, minus 25 divided by 2 times F0. That means 2 into 30 minus F minus is equal to 25 minus F1. F1 is the frequency of class interval above the mode class. Now, above the mode class interval is 30 to 34 and its frequency is 17. So, minus 17 into I means length of class interval. Easily we can find that the length of each class interval is 5. So, multiplied by 5. Now, if we calculate, we get MO is equal to 24.5 plus 30 minus 25, that means 5, and multiplied by 5, that means 5 into 5 divided by, the calculation is 18. That means mode is equal to 24.5 plus 25 upon 18, and which is equal to 24.5 plus 1.38, and which is equal to 25.88. That means mode of the given distribution is 25.88. In this way, in this part, we have seen the meaning of mode and how to find the mode from ungrouped data as well as from group data. In next part, we will consider the combined mean and other things.